So hopefully you had a chance to watch and actually pay attention to those two videos. You hopefully connected the idea that the sine wave that comes from trigonometry is an essential part of why music works. It's a critical aspect to medical imaging. It's also the reason your car works, the reason you have clothing, the reason your phone works. It's the reason you get wireless internet. All those things are associated with circular motion and the sine wave in some application or another. What we're looking at today is the very basics, the very bottom of the staircase of knowledge in laying out how we get to a sine wave in trigonometry. Your bell work looked at this idea of what is the Cartesian coordinate system. A Frenchman by the name of René Descartes was instrumental in taking the two number lines, the horizontal number line and the vertical number line, and putting them together at right angles. And when he did that, he made a way for us to numerically quantify navigation in a two-dimensional plane. So no longer was it just kind of randomness. You know, you go over to up 3 and you have a location right here. If you go back 2 and down 3, you've got a different location. So you have everything you need to navigate, and now it's quantifiable with numbers in the two-dimensional plane, the flatness of Earth, so to speak. The coordinate system, a lot of people think this is a graph. It's not a graph. A graph is a visual list of all solutions. And you might remember from yesterday or Friday that a solution is a value of the variable, plugs in and makes the statement true, makes the left hand have the same expression, same value as the right hand expression. So a graph is a visual listing of those solutions. Those solutions come in the form of ordered pairs, which are the coordinates. Because you have two axes, you're divided up into quadrants. Move it counterclockwise. And the coordinates are what wind up being those solutions plotted. The ordered pair is what identifies the location of those coordinates. Over 2, up 3. Very basic stuff, right? Okay, well, it's our job to get from the very basic stuff to the foundations of trigonometry and being able to graph a sine wave. And the graph of the sine wave will be the visual list of all solutions there. First, let's review that quadratic that you were asked to solve using the quadratic formula in your bell work. Had to rearrange and bring the 2 over to that side, get the 7x squared in front. So I have what A, B, and C are. A is 7, B is 2, C is -1. You're going to have to excuse my marker carried on my slate with me. I'm using the digital stylus out of my tablet. And x equals -b plus or minus square root of b squared minus 4ac all over 2a. Yes, you have to know it that fast, that good. That, I mean, it's got to be automatic. I'm going to then plug in. Most folks have no problem plugging in the two b values here and here. Most folks have no problem plugging in the two a values next to it and below, and the c value. What they do end up struggling with is getting the sign right on this term. 30 years of watching this happen, that's where the mistakes come from. Count your negative signs first and decide what the sign of that term is going to be. 4 times 7 is 28, times 1 leaves it at 28. There were 2 negative signs is a positive 28. Square the 2, you get 4. 4 plus 28 is 32. And 32 is got a factor of 16 as its largest perfect square. We'll take the square root of 16 and the square root of 2. We'll end up with 4 radical 2. That's the places where most of it happens and becomes a mistake. -2 is the b value up front, 14 is the 2a value down below. Please don't forget to look for the clown face. Check this number, and this number to see if there is something that will reduce. And right now, I know I put a 17, but I don't mean a 17, I mean a 14 down there. Thinking about the 14 and reducing the 2 out gave me a 7, put the 17 with it. But yeah, that's what we're going to do. We're going to reduce a 2 out of all those. 2 comes out of there, leaves me -1. 2 comes out of there, plus or minus 2, radical 2. And 2 comes out of 4, leaves a 2. Remember, the plus and minus are there because we're considering not just the principal square root, but the secondary root as well. And that's 2 values of x. -1 plus or minus, sorry, plus 2 radical 2, all over 2, and x equals -1 minus 2 radical 2, all over 2. That's what you should have got from the bell work there. Check it on your calculator. Hit the mode 5, 3. Type in A, B, and C. You should end up with those 2 values, the plus and minus, for those solutions. On to today's information. Use the Pythagorean Theorem. Pythagorean Theorem is from an old Greek guy, Pythagoras, long before René Descartes' time. René Descartes puts together the Cartesian coordinate system. Pythagoras is scribbling in the sand, trying to figure out ways to handle right triangles. We notice then on the Cartesian coordinate system that anytime we connect a distance between 2 coordinates, the difference in their x values and the difference in their y values, the rise and the run and the rise, form a right triangle. And so Pythagoras' idea from way back in Greek times matches up with René Descartes' Cartesian coordinate system and starts to give us the foundations of where circles come from. You're like, circles? How does that? Oh, well, there's the unit circle. You might remember that from Algebra 2. And how it relates to generating a sine wave. We'll get there. We'll get there. But first, you have to have mastered these. Use the Pythagorean theorem to calculate the distance between the points 2, 1 and 6, 3. 2, 1, 4, 5, 6, 1, 2, 3. Now, the first thing you do with 2 points is you can make a line, right? But what do we know about every line? Every line has slope, correct? And the rise and the run between these form the legs of Pythagoras' triangle. A and B, correct? How do we figure out what that A and B are? Well, we would have to either count 1, 2, 3, but sometimes the values between these get very difficult because they're really large, and so you don't want to count them. You'd have to just do the subtraction. y2 minus y1. Okay? I think I got that point wrong. I think I got that point right there, and it should have been down here. Now I got to start all over again. No, I'm not going to start all over again. Sorry, guys. Too much recorded already. I'll just slide my triangle down there. There we go. Good thing we have a numerical way to count. So we're over at 6. 1, 2, 3, 4, 5, 6. We're up at 1, 2, 3. I went up to 4 initially. We got our second ordered pair there, and we're back to talking about the y2 minus the y1 would give us the rise on that triangle of 2, and the x2 minus the x1, 6 minus 2, would give us the run on that triangle. And therefore we have the legs for Pythagoras' theorem, because we now can tell the distance between those 2 points. It will be the c distance. A squared plus b squared equals c squared. So I would have 4 squared plus 2 squared not jump the gun on the radical there. 16 plus 4 gives me 20. How do I figure out the distance? That's certainly not 20 boxes worth. 20 boxes would be as wide as my coordinate system is. It's not 20 that is the hypotenuse, it is the square root of 20. Now, I brought the radical in there. I should be considering plus and minus, but the physical nature of what's going on here says, no, it's only the plus. And so if it's only the plus, then I should look at what C equals. I believe there's a 4 and a 5 to make up that radical. The square root of 4, the square root of 5. I should be at 2 rad 5 as the value of that hypotenuse. And radical 5 is a little bit bigger than 2, and 2 times 2 is 4. And if we were to measure across here, it would be a little bit more than 4 squares for the hypotenuse. So this, understanding the Pythagorean theorem, understanding right angles in the Cartesian coordinate system, leads us to the distance formula. And the distance formula is nothing more than the rise and the run. Wow, it's late. No, it's early. Maybe I'm medicated. The rise and the run, and they are squared because we're talking about them as legs of the triangle. So when we see the distance formula, we realize, no, it's not a separate weird formula. It's just the Pythagorean theorem merged with René Descartes' ideas. 2, comma negative 1, 2, 3, 4, 5, 6, and 5, comma 1, 2, 3, leave me with a rise and a run on a right triangle that would let me solve for the hypotenuse, which is the distance between the two ordered pairs. So how do I calculate the rise? Well, the same way I always calculate the rise. It is y2 minus y1. 3 minus negative 6. 3 minus negative 6 gives me 3 plus 6, which is 9. Add that to the run and square the run. What's the run? Well, the run is 5 minus 2. 5 minus 2 is 3. When I square them, 81, 9, 90, 3 radical 10. Square root of 9 is 3. Square root of 10 is a 2 and a 5. That's all we got. Square root of 10 is a little bit bigger than 3. 3 times 3 is 9. We got something that's a little bit close to 9 there on the value of that hypotenuse. The distance formula is an extension or just a renaming of Pythagoras' theorem. C squared got its square root taken, and we're calling it d the distance. So is this a hard formula to remember? Not if you know slope. It's not. It's run squared plus a rise squared, and that's adding. So if you wanted to do the rise squared plus a run squared and kind of keep it the same order, you certainly can. So looking for the pattern to help you remember the formula is important. Remember, outside is positive, inside is minus, but you already knew that because you knew how to find rise. Rise runs with y's, correct? Rise and run. It's just the legs of a right triangle. You have a handout. Take a moment right now. I'll give you several moments. And find the distance between the points. You're like, wow, those are radicals. Yeah, that's fine. It's not a big deal. It's y2 minus y1 and x2 minus x1. And hopefully you remember how to add and subtract radicals. Oh, they have like radicands and like indices, so you should be fine. No, really. Find the distance between them. I'm waiting. I'm still waiting. Keep going. Pick up your pencil and get it done. Come on. Yep. Distance is the square root of, and then it's rise and run. Yeah, the rise is here with the y's. We had y2 minus y1, so we had negative 8 rad 11 minus 3 radical 11. And negative 8 minus 3 is negative 11 radical 11. And we're about to square that. You square the negative 11, you get 121. You square the radical, you get times 11. I'll let you multiply that out. That's 1210 plus 121, isn't it? Okay, we got that much. Now I better find the run and square it. That's x2 minus x1 minus a negative 7 will be a positive 7 radical 11. 5 plus 7 is how many? Oh, it's 12 radical 11s. And we're going to square that. When we square the radical, it becomes 11, and we square the 12, it becomes 144. That's 1440 and 144. So that's 1584. And we're supposed to do what with those two numbers? We're supposed to add them. So we get the square root of 2,800, 900. All right, let's put it together. $15. You'll have to get an estimate of that on your calculator. I'm not going to spend the time to break it down. If you have your Casio 115 ES Plus, you might type that radical in there, see if it simplifies. Okay. This is the distance. Something we need to pay attention to right about now is this notion of the distance formula right here. And what if I were to hold one of the two values, one of the two ordered pairs, constant? What if I were to hold the x1 and the y1 in a single location? And then I was to try every other x value around and y value around that had that same distance. I would essentially be looking at this circle all with the same starting point going out to the x2, y2, or move that to a different x2, y2, or move it to a different x2, y2, or move it to a different x2, y2. As long as I hold the distance value constant, I should now have the equation of a circle. There are triangles within each point. From the center to the edge, preserve the radius. I get a run and a rise. If I go to here, it's a little more challenging to see it because the run has evaporated into 0. Go over to here, I get a run and the rise. I get the run and the rise. I get the run and the rise. They're all producing the same hypotenuse. And so this is the foundation for the circle. Why is the circle important? Well, the circle is probably important because as I move around it with those different triangles, and I measure the length of the rise each time I move around the circle and plot where I am in the rotation of the circle versus how big that rise is, I get the basis of all music, the sine wave. I get the basis of the electromagnetic spectrum, the sine wave in compressed and stretched forms. I can see bones because the X-rays in their shadow. I can kill cancer cells because the gamma rays have such a high frequency that their high energy produced will kill cancer cells. If I'm sitting in my car and I turn the motor on, the crankshaft rotates and the piston goes up and down and up. And the spark plug fires, boom, and the piston drives down. And why is the shirt that you're wearing holding together? Because the sewing machine has a wheel at the end and it turns the needle and the needle goes up and down, and right at the bottom a line comes through to stitch through the loop created by the thread. And why are you hearing my voice? Because the sound from the speaker is pulsating the air and traveling in a sine wave. Everything is associated with this phenomena, and this phenomena is based on the triangles that we see, and the leg, and the run, and the rise, and the hypotenuse being constant each time. And so this becomes the basis of everything we enjoy in the modern world. The equation of a circle is back to a squared plus b squared equals c squared. Put a square root over both sides. You have the distance formula. Drop out the h and k to a separate point that moves, and you have the line segment, and it all goes back to rise and run, and a squared plus b squared equals c squared. You have to remember what the radius, what the ordered pair that at the center of the circle is. You need to know the equation of a circle with hk at its center, the one point that we held constant the whole time, while the other points moved around and we kept the same distance each time, the radius. Write an equation of the circle with a center at 2, 1. Oh, you mean you're telling me what the h value is and what the k value are? -2, 1. And a radius of 3. So 3 goes there, k is 1 there, and h is -2 there. Shouldn't I have the equation of a circle pretty easily? Double negative sign means x plus 2 squared, y minus 1 squared equals, what was that radius again? Oh, it was 3 squared. And this says, hey, hold 1 point constant. Find a bunch of other xy's that will always give me 3 squared when I put them in. And as you plot those solutions on the coordinate system, those solutions will give you the graph of a circle, because the graph is a visual list of all solutions. And this is how we write the equation of the circle. Remember, the circle is about 1 point being held constant and finding another point that matches a distance. That distance squared should be 9. So if something comes out less than 9, then we would expect that point to be on the inside of the circle. If something comes out to be greater than 9, we'd expect the point to be outside the circle. And if something comes out to be exactly 9, we'd expect to lie on the circle. And the only way I'll know is if I test it. I'll test it by putting in the x value. Negative 4, adding it to 2, get negative 2, square it. You're going to have 4. Put in 3 for y, minus 1, get 2, square it. 4 plus 4 is 8. How does that compare with the distance that is on the circle? I think it's less than 9, isn't it? And if it's less than 9, this point lies inside the circle, because this is the distance from the distance formula. And every xy that satisfies this thing will all be on a distance from the given point of negative 2 comma 1. And from that, it should be 9 every time. Did I say 9? I meant 3, because that's not the radius, it's the radius squared, correct? So this is radical 8, 2 rad 2 squared, 8. But it's still less than the 3 squared, which is 9, and so we know that point had to lie inside the circle and not on the circle. So no, it does not lie in the circle. You know, if you got a segment, it might be important to find the center of it, particularly if you're talking about some kind of a circle. Might be helpful if you knew a diameter to be able to predict a midpoint, so you'd know the center HK is, so you could start producing the radians. Well, this is another familiar formula. That familiar formula is the average. If you want to know what's in the middle of two numbers, you take their mean, add one to the other, divide by how many values you had. It's the average of the x's, comma, the average of the y's. Average your two x's. 2 plus 4 over 2, comma, average your two y's. Negative 15 plus 5 over 2. Was there any subtraction here? No, because it's average and average. It's not like the rise and run scenario that we had leading up to the distance formula. It's 6 divided by 2, which is 3. It's negative 10 divided by 2, which is negative 5. And this is the middle point between the two endpoints we've been given. Real close, quick. 2 comma negative 15 would be way down there. 4 comma 5 would be up here. And what do we say it was? About 3 comma negative 5, the midpoint. Seems reasonable, doesn't it? There's another one from your handout. Handout is what you should be working on when we're done here today. On the midpoint between these two, well, I'd have to average the x's, and then I'd have to average the y's, wouldn't I? If I got to average the x's, I would have 13 radical 7 minus radical 7 all over 2. And if I'm going to add the two y values and average them, I'd have negative radical 10, and I'd add it to 0. Put it all over 2. What do we end up with? Well, 13 minus 1 would be 12 radical 7s over 2. That would give me 6 radical 7s. On the next one, we have negative radical 10 and 0, all divided by 5. The 2, you'd really like to go into that 10, but that 10's inside the radical. So we leave it as negative rad 10 over 2. This is the midpoint. Okay? Let's take what we've talked about then and take a look at these two ordered pairs, which are the endpoints of the diameter. If they are the endpoints of the diameter, -2, comma, -3, and -2, comma, 8, I should be able to find their midpoint and then be able to tell you what h and k are, because they're on the endpoints of the diameter of a circle, correct? If I know what h and k is, then I could certainly figure out the distance from that to either of the 2 points, or I could take the distance of the radius, and whatever that is, take half of it, or the distance of the diameter, whatever that is, and take half of it to identify what the radius is. So find the length of the radius, find the center of the circle, write the equation of the circle. Well, let's go. First, we'll want to figure out what the average of the x's is. I believe it's -2. Find the midpoint. Going to work with x's together. Pretty obvious when you have two of the same numbers, their average is going to come out to be that same number. And then average the y's, 8 and -3. You get 5/2. Okay. I have the midpoint of the diameter, and the midpoint of the diameter is the radius. Sorry, the center. If that's the center, this is h and this is k. Now, do you want to deal with the fractions to try and figure out what that radius distance is? Because we can put it in there and figure it out. But I think you'd probably rather deal with the entire diameter and cut it in half, given that everything in the two endpoints were actual whole numbers. So I think you ought to use the distance formula on the endpoints and then cut that in half to figure out what the radius is. If I know how long the diameter is, I cut it in half, I find how long the radius is. So we'll find the distance. We'll find the distance by y2 minus y1 and x2 minus x1, the run squared, the rise squared. -2 minus a -2 gives me 0, and I'm supposed to square it. When I square 0, I get 0. To that, I'm going to find the rise squared. That's 8 minus a -3. 8 plus 3 is 11. 11 squared is 121. And now I get the square root of those and find out that I have 11. The diameter's distance equals 11. What are we going to do to find the radius? The radius is equal to 11 cut in half. So the radius is 5.5, or 5.5. Do I know h? Do I know k? Do I know r? If I know h, if I know k, and if I know r, I better know the equation of a circle. Remember how I said you need to know it? Anybody remember it? X minus h, because it comes out of the distance formula, which is from the Pythagorean Theorem, which is rise squared and run squared, plus y minus k. Alphabetical, the later one comes with a later letter, the beginning one comes with the earlier letter, squared equals the r squared, correct? All right, what was my h value? I think I know what my h value was. My h value was -2. My k value was 5/2. My r value is 11/2. That way when we square it, it won't be so ugly. And my x minus a negative 2 gives me x plus 2 squared plus y minus k. My k was 5/2 squared equals my radius squared. You want to square 11 or do you want to square 5.5? I think I'd rather square 11 and 2 is 121 over 4. The equation of the circle. Okay? Do you need more on that? YouTube is your friend. Everything that we've talked about here, you should be able to find and get more help from YouTube. And make sure you get the worksheet done. That is 1.4. And there's a good chance I'll probably see you tomorrow. Don't groan. Be happy. All right. Have a great day. Get that stuff done. Do not waste your time. Get your cell phones put away and get to work. All right. Miss you guys. Bye.